It looks like some of the questions have an answer key number choice, which may not be correct. And I'm not saying this is for sure. We've done this question, we've seen the paper yesterday. There's very much a chance that we guys have looked at the question, solved it one interpretation, something else is possible. But prima facie, it looks like some answer key part is incorrect. And we have basically tried to solve it in one way, which we are assuming or hoping to be the correct way. Describe our method and then try to think about why the wrong answer is wrong, right? And then showcase it, just so that we can all get into a huddle and say, hey, this is indeed correct, or hey, we guys here have made a mistake, this is the right interpretation and indeed the exam is correct. And so it's one way to just among us see if we can be clear about what is the right answer, why the right answer is the right answer, and then resolve this seeming discrepancy in this. And so please do send us comments on whether you agree with the solution or whether we have made some mistake. And let's also think about what are the further steps to take. How do we appeal? How do we take it forward? All of that. 3 questions where I thought the solutions didn't match. And so the answers didn't match. Question where the answer didn't fall in place. Let's look at this. A government office assigns a distinct license plate for each vehicle registered under it. Each license plate contains 2 letters of the English alphabet followed by 4 digits. And so 2 letters followed by 4 digits. This is 0 to 9. This is A to Z. Nice. In order to avoid confusion, no license plate is allowed to contain both the letter O and the number 0. It's one of those convoluted questions. I don't know how it will be confusing. You put an O here, 0 there, it comes in different digits. Not like it can get confused, but hey, this is the question, so let's follow it. In order to avoid confusion, no license plate is allowed to contain both the letter O and the number 0. That is, I can have PO 2356. I can have KL 2904. Both are allowed. This is allowed. This is allowed. What can we not have? We cannot have PO 2065. This is not allowed. And so, no license plate is allowed to contain both the letter O and the number 0. What are the maximum number of vehicles that can be registered by this office? Nice. And so, let's attack this. So, we cannot have a both. We have dash dash and dash 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 dash. Right? This is a registered number plate. So, simple rules. A PO is different from an OP. A 2356 is different from a 3256. Order matters. Right? And of course, I can have 6600. Repetition is allowed. Right? Nice and simple. The same digit can appear over and over again, and the same letter can appear over and over again. Only condition is it cannot contain both O and 0. That's not possible. Right? So how do we do this? We can say, okay, we'll have O and no 0. Right? O being there and 0 not being there. Right? Then we'll have a mechanism. This is there, 0 not there. Right? O being there, everything being there. Right? So no O, O being present, 0 not being present. Right? O not being present, no 0. O not being present, 0 being present. Right? So O and no 0, no O and no 0, no O but 0 being there. The only thing we need to avoid is no O and no 0. That's the only thing we need to avoid. And so nice, beautiful. We've got the hang of this. Now let's attack this. So if a 0 is not present, O may or may not be there. Either way is fine. If 0 is not present, then O could or could not be there. Both are fine. Right? So you can say, let me assume that this side O is present, and then there is no 0. Right? O is present, there is no 0, or O is not present, there is no 0. And then if 0 is present, what do we do with this? And I can work it both ways. And so we go step by step. Let's say this is without O. This 25 into 25. O not being there. O not being there, I could have a scenario where 0 is present, 0 is not present. Both I can count. Whether if 0 is present, I can count that. 0 is not present, I can count that. Or I can count 10 into 10 into 10 into 10. There could be 1 0, 2 0, 3 zeros, 4 zeros. All of those combinations can get counted because I am not including O. If O is not there, whether 0 is present or not present, I am counting everything. Next step, what do? I say, okay, let O be present. Let there be O in it, which means 0 should not be present. No 0 here. Right? So O is there, 0 should not be there. O is not there, 0 may or may not be there. Counting everything. If O is present, then 0 should not be there. If O is present, I could have dash O, O dash OO. Dash O, there are 25 possibilities. O dash, there are 25 possibilities. OO, there is one possibility. 25 plus 25 plus 1. Let's see. 51 possibilities. Here, 0 should not be present because O is present. I cannot have 0 also. So 0 should not be present. Or I am counting 9, 9, 9, 9. 9 into 9 into 9 into 9. Right? 51 into 9 into 9 into 9 into 9. 25 into 25 into 10 power 4. This is 625 followed by 4 zeros. This 9 into 9 is 81. 81 into 81. And to just be 6561, I think. 81 into 81. 18648. 6561. 51 into 6561. This is 6250000. Nice. 6561 into 51. 6561. 5 30 03 28 82 30 plus 2 32. 1 1 6 4 1 3 3 3 4 6 1 1 6 2 5 0 0 0 0. This is a 7-digit number, it's a 6-digit number added to 3 3 4 6 1 1 1 1 6 4 8 5 6 5 8 4 6 1 1. 658 4611 is there among the choices? Yes, that is indeed the right choice. Right? However, I think the answer script gives us this answer, which is rather weird. Right? So that should not be counted. Something funny there. It should technically. This seems like the right answer. And we said, okay, how did this come about? What is the funda behind this? So let's think about it. Let's see if we can find what is the reasoning behind this. So we said let's try that. So I'm going to simplify this and say erase everything on slide, erase everything on slide, erase everything on slide. Okay. What we did when we said look nice, we have a dash dash and dash 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 dash. 25 into 25, 10 into 10 into 10 into 10 seems clear. 10 into 10 into 10 into 10 is 10 power 4. This is 625. 625 0 0 0 0. This number is 1068 5236. Subtract from this, the 5236 is going to stay intact. 8 minus 5 is 3, 6 minus 2 is 4, 10 minus 6 is 4, 4 4 3 5 2 3 6. I'm just working backwards to see, hey, What might have caused this? Where might this have come from? 4, 5, 3, 5, 2, 3, 6. We struggled long and hard. We couldn't fit this. This is there as one of the choices. Mind you. Instead, this seems 4 plus 4, 8 plus 3, 11, 16, 18, 27. It's a multiple of 9. There's a bunch of 9s in it. Perhaps. So maybe, let's just try this out. 9, 9, 9, 9. Possibilities with no 0 in them. But hey, could include O. I'm going to try to find this number. Right? So 9 into 9 into 9 into 9, which is 6561. We've already done that. Into 676. So 6561 into 676. Of course, you're going to be given a calculator. Hey, I don't have it. 6, 6, 6, 36, 6, 3, 30, 33, 3, 3, 39. 7, 42, 2, 4, 35 plus 4, 39, 9, 3, 42 plus 3, 45. And then 3, 9, 3, 6, 6, 6, 3, 1, 4 plus 2, 6, 6 plus 6, 12, 1, 10, 19, 25, 5, 2, 5, 10, 13, 3, 1, 10, 14, 4, 1, 4, 4, 3, 5, 2, 3, 6, which is indeed this. Or this is telling us that this answer has come from doing 25 square into 10 power 4 plus 26 square into 9 power 4. That is, and no O, all combinations, no 0, all combinations. Sitting inside that will be a set of numbers that have no O and no 0. No O and no 0 will be here and here, or common to both of these will be a 25 square into 9 power 4. This is O, this is 0. This is no O and yes 0. This is yes to O and no to 0. Sitting in both of these lists will be no O and no 0, which is 25 power 4, 25 square into 9 power 4. That chunk is getting double counted if this were to be the answer. Which number? Let's find that number. Why not? So 6561 into 625. I'll be super happy with the calculator, but hey, we don't have one. 30, 0, 3, 25, 28, 8, 2, 30, 32. 2, 12, 2, 1, 10 plus 1, 11, 13, 6, 6, 6, 36, 6, 3, 33, 3, 3, 39, 5, 2, 10 plus 6, 16, 6, 1, 3 plus 1, 4 plus 6, 10, 0, 1, 9 plus 1, 10, 0, 1, 2 plus 9, 11, 1, 1, 4, 1, 0, 0, 6, 2, 5. My gut feel is, if we took this number, added this, we'll get this. 6584611 plus 4100625 should be this number. That's the missing part. This number is getting double counted when we go to this answer. What they have done is no 0, no O, all zeros, no 0, maybe O also. Then you should subtract all combinations where zeros and O's could be allowed. That part has to be reduced from this number. If we do that, we'll come back to this number, which is precisely the answer we got in the first place. And nice, beautiful question, because it's a layered question, wonderful question. But we don't want to say, become so cocky and say they got it wrong. Maybe still a possibility that we've got something wrong. We tried long and hard, and so this one is a nice process to get here. Then we said, okay, maybe we are missing something. See, what is the mechanism to get this? The mechanism to get this, these two get added up to that, it falls in place. But if we do that, then we are double counting all combinations that have no 0 and no O. That will come in both of these lists. So maybe we reduce that. Yeah, we reduce that. From this number, we reduce this, we'll get this. So through multiple rounds of reconciliation, it looks that this is right, in which case we need to have another look at the answer key. But hey, this is what we have. If you have anything interesting through comments, discussions, solutions, all of that, please chime in with those. Lovely. Nice. The domain of the function, fine. Domain of this. So what is under the square root? What is under the square root? This part should be greater than or equal to 0. Simple rule. I don't have square root of a negative number. So this part should be greater than or equal to 0. That's all I'm solving for. So I'm saying log of 3x minus x square by 2 to the base 10 is greater than or equal to 0. 10 power 0 is 1. So if you look at this, log 10 is 1, log 1 is 0, log 1.5 will be 1 point something, log 3.5 will be 1 point something, sorry, 0 point something, not 1 point something. Log of 1 is 0, log 10 is 1. And so log 1 to the base 10 is 0, log 10 to the base 10 is 1. So log of 5 to the base 10 is whatever, 0.69 something. We know that. That is greater than or equal to 0. Can log of this number be less than 0? Yes, it is possible when this is less than 1. So 3x minus x squared by 2, if that were 0.5, what is log 0.5 to the base 10? That will be less than 1. What is log 0.1 to the base 10? That will not be less than 1, will be less than 0. Log 0.1 to the base 10 is minus 1. 10 power minus 1 is 1 by 10, which is 0.1. So this thing has to be greater than or equal to 1. If it is equal to 1, then we get 0, which is fine. If it is greater than 1, this will be positive, that will work. Or this inequality rather nicely boils down to 3x minus x square by 2 greater than or equal to 1, or 3x square, sorry, 3x minus x square minus 2 by 2 greater than or equal to 0, or x square minus 3x plus 2 less than or equal to 0, x minus 1 into x minus 2 less than or equal to 0. Nice quadratic inequality with two roots 1 and 2. X should lie between the roots. X belongs in the range 1 to 2. Hopefully that's there in the choices and we are through. It should be this, but the answer key perhaps says this. Again, something to worry about. The answer should be between 1 and 2. Again, we tried several things. We substituted x equal to half. So 3 into 1 by 2 minus 1 by 4 by 2. That's what this is. Just 1.5 minus 0.25. 1.25 by 2, which is 0.625. Log to the base 10 of 0.625 is negative. So half does not work. 2.5 will probably not work either. So this does not work. This works. It should lie between 1 and 2. All numbers into 1 and 2 inclusive. So once again, something I think we probably need to have another look at the solution key, or we need to appeal or do whatever that process is. In an 8x8 chessboard, numbers are placed on each of the 64 squares such that the number on each square is the average of its neighboring squares. That is, the squares with which it shares a side. Okay, not all the squares are on, only the ones where it shares a side with. Also, it is known that sum of all the numbers is 640. Which of the following is true? There exists a way of placing the numbers in the chessboard such that the average of the numbers on the 4 corner squares is strictly greater than 10. The corner squares are not 10. Greater than 10. Average of all 64 squares is 10. Total is 640. The 4 corner squares are higher. There is some way of doing this. There exists a way of placing the numbers in the chessboard such that the product of all the numbers must be strictly less than 10 power 64. Sum is 640, average is 10, arithmetic mean is 10, geometric mean is less than 10. Possible. There exists a way of placing the numbers in the chessboard such that the average of the numbers in the 4 corner squares is strictly less than 10. Here it's strictly greater than 10, it's strictly less than 10. And so the 4 corner squares is a mechanism to have an answer which is more, mechanism to have less. This is saying Arithmetic mean being greater than geometric mean. So, the number of ways the chessboard can be filled subject to the given conditions is less than 10. This is the most interesting. I'm going to look at this question and say, hey, very interesting. I'm going to have one way of solving this. One way of getting one set of numbers. Right? The one thing that jumps out is each time it's the average of all of this. Stick the same number everywhere. Sum of all this is 640. 640 by 64 is 10. Suppose I put 10, 10. Everything is 10. This will work. Average of any number of 10s is 10. I don't have to worry about anything. This works. So I've got one way of filling where every number is 10. All 64 squares are 10. So 4 corners being strictly greater than 10? No. Strictly less than 10? No. Geometric mean less than 10? No. Product of all this will be 10 power 64. This is one possibility. The question practically says, hey, this possibility, the seemingly trivial possibility exists. Can you tell me that there exists one more where all numbers are not equal? If you can find one more where all numbers are not equal, then we can say, okay, there is a possibility that all numbers are not equal. Then the geometric mean will be less than 10, in which case 10 power 64, that condition will get satisfied. In that, we'll worry about corner squares and then we are through. And so practically this question comes down to, is there a non-trivial solution? Right? There's a beautiful answer to this. So average of each square is the average of its neighboring squares. So, there are 3 types of squares possible. Very interesting. I can say my square could be this. In which case my neighboring square will be this and this. There are 2 neighboring squares. Or my square could be this. In which case the neighboring square could be 1, 2, 3 neighboring squares. Or my neighboring squares could be this. In which case neighboring square will be 1, 2, 3, 4 neighboring squares. I could be exactly in the corner. I could be on the side but not the corner. I could be somewhere in the middle. All 3 are possible. Right? Now I'm going to say, if I'm filling all these numbers and all numbers are not equal, that's what I'm thinking. All equal, there's one possibility. All numbers are not equal. Then I can find one number that is the least. It need not be unique. There could be 25 numbers that are all equal to 9.8. Possible. In which case I'll pick one of those 25. There's one square that has a number that is less than or equal to all the 63 other squares. And I can find one square like that. That one square could be my purple square, my red square or my blue square. Any one of these is possible. Find the least number could be here, here or here. By least, I'm not saying uniquely least. I'm saying least as in less than or equal to the other 63. It could be equal. It's not greater than. Right? So I'm going to say nice. So I'm going to identify this least square. I'm going to say let the least square be here. Very interestingly, every other square is greater than or equal to this. Beautiful. This square is the average of these 3. Each of those 3 is greater than or equal to this. Average of 3 numbers greater than this number has to be equal to this number. Not possible. Average of three numbers is this. Each of those 3 numbers is greater than or equal to this. They cannot be greater than this. They have to be equal to this. If average of 3 numbers is 4, I can have 2 numbers higher than 4, 1 number less than 4. 1 number higher than 4, 2 numbers less than 4. All 3 numbers equal to 4. What I cannot have is all 3 numbers greater than 4 or all 3 numbers less than 4. If something is greater than 4, it has to be offset by something that's less than 4. Each of these 3 numbers is greater than or equal to L. 3 numbers greater than or equal to L cannot give an average of L. The only way they can give an average of L is they are all nicely done. Now what do I do? Very simple. I look at this number, this cell which is in A4. A4 is the average of these 3. This is L. All numbers are greater than or equal to L. This should be L. This should be L. I look at A3, this should be L, this should be L. I look at this number, L, 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 this should be L. I look at this number, L, 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 L. I look at this number, these 4 should all be L. I look at this, these 4 should be L. How do you get the hang of this? If this is L, all of these should be L. And, or I can say, if this is L, my corner square, that is L, then this should be L, this should be L. This is L, these 2 are L. This is L, these 3 are L. This is L, these 2 are L. This is L, these 2 are L. This is L, these 3 are L. This is L, this is L, this is L, or everything is L. If I take a middle square to be the minimal one, then this should be L, this should be L, this should be L, this should be L. This is L, this are L. This is L, this are L. This is L, this and this are L. Or if I take one of the squares to be the least among all of them, joint least, not uniquely least, but least, all other squares are greater than or equal to this, then we can slowly demonstrate in 3 steps, 4 steps, 5 steps, intuitively, clearly, that all other cells should be equal to this, otherwise not possible. Which means there is one way and only one way of filling this. That means if I know the sum is 640, I can say for sure that all squares have 10 in them. Now let's go to the choices. There exists a way of placing the numbers in the chessboard such that the average of the numbers in the 4 squares is strictly greater than 10. No. There exists a way of placing the numbers in the chessboard such that the product of all numbers must be strictly less than 10 power 64. No. Product has to be 10 power 64. There exists a way of placing the numbers in the chessboard such that the average of the numbers on the 4 corner squares is strictly less than 10. No, all are 10. The number of ways the chessboard can be filled subject to the given conditions is less than 10. Yes, there's only one way. Which means that this has to be the right answer and not that. Thank you guys. Best wishes for your results.